This is an extract from the Leader podcast by the Evening Standard. The whole thing is available on all major podcast providers.
Hidden pockets of ice on the moon could be much more common than scientists previously thought, and this discovery could mean water is going to be more accessible for astronauts on future lunar missions. Paul Hayne is an assistant professor in the Laboratory of Atmospheric and Space Physics at University of Colorado Boulder. He assessed a whole range of possible sizes for these so-called cold traps. He joins me now. Paul, what did scientists already know about cold traps?
Right, so we've been studying the cold traps for about a decade now with NASA's Lunar Reconnaissance Orbiter spacecraft, which is still in orbit at the moon. And the focus for that 10 years or so has been pretty firmly on the largest cold traps that we can see from orbit. These are typically inside big craters with names. They're very prominent in both polar regions, and the cold traps are the portions of those craters that never see sunlight. And this is because the spin axis of the moon is not tilted very much at all relative to the direction of the sun. And so if you imagine standing at the poles of the moon, you would see the sun revolving around the horizon over the course of the lunar day. And so if you drop down inside a crater, then the walls of the crater will block the sunlight. And so that's what's going on inside these big, dark shadows. They literally never see sunlight, and they haven't for at least 1 billion years. Because of the lack of an atmosphere on the moon, that causes the temperatures on the surfaces of these cold traps to be extremely low. And the coldest surfaces we've measured there are only just a bit above 20 degrees above absolute zero. These are areas where if ice gets trapped in there, the ice will behave basically like a rock for billions of years. It's not going anywhere. What's new here is that we started to realize that besides the big cold traps that are obvious from the Lunar Reconnaissance Orbiter observations, if you zoom in and you keep zooming in, you see more and more of these shadows on smaller and smaller scales.
So how many of these cold traps have been found now, and how much water could these potentially hold?
So the number of cold traps on the moon, based on our research, is upwards of 10 billion. And the vast majority of those cold traps are on this small scale between the size of a small coin and a meter in size. And we actually don't have a direct measurement of the amount of water inside these cold traps yet. We plan to very soon through NASA's Artemis program and the other lunar landers that are upcoming. But if we're right and these cold traps are every bit as good as the bigger ones, we anticipate something like a billion kilograms or so of water inside these micro cold traps.
What do your findings mean for future missions, either to the moon or elsewhere in space?
It's really exciting because this means that the water could be much more widespread and accessible to future astronaut and robotic missions, because the micro cold traps are scattered all over the surface within about 10 degrees of both poles, as opposed to trying to venture deep inside one of these big, dark, cold shadows inside one of the larger craters. The astronauts could stand in sunlight and bend down or reach a tool into a meter-sized cold trap and extract ice. So we think this is going to have important implications for future exploration, both in terms of the scientific analysis of the water and trying to understand where it came from, and also for exploration purposes, for making rocket fuel and also drinking water for the astronauts.
So you mentioned that you haven't actually seen these smaller ice traps. What is the next stage of the research? Will astronauts or rovers be sent to the moon to explore this further?
Yes, we have several upcoming missions, including one that will be the first of NASA's polar lander missions. on which we have an instrument called the Lunar Compact Infrared Imaging System. So it's an infrared camera that basically follows on from the work that was done using the infrared instrument on the Lunar Reconnaissance Orbiter called Diviner, but doing so from the surface. So we're going to land very close to the south pole of the moon, and we're going to do a survey using panoramic images to take pictures of these micro cold traps for the very first time and measure their temperatures. And then other instruments on the same lander will make an assessment of how much water is contained inside these permanent shadows.
And are there any implications for how we understand how water formed on Earth?
Well, I would say in addition to the exploration importance of this discovery, it's also important for understanding how the water got to the moon in the first place, which helps us understand how Earth got its water. So by analyzing the water and other volatiles inside these shadows on the moon, we can lend insight to the question of how Earth got its oceans and other questions about how water moves around in the solar system.